My name is Chris Levy, as was said, and today I'm going to talk to you about the power of modern version control with reference to Git and GitHub, mostly. And once we've talked about those two, I'm going to talk to you about what I mean by the power of modern version control. Firstly, a little bit about me. Chris Levy, obviously. I'm on Twitter at Levovsky. I've worked with PHP for about 10 years, give or take. Originally, I trained in Java at university because that's what I was interested in, but I changed to PHP to get a job. And I haven't touched a single line of Java ever since. Currently, I work with Zen Framework 1 and Zen Framework 2 on different projects, bespoke work, some products type stuff. I've got experience in other frameworks too, Symfony, a little bit of Symfony, Magento, which I don't normally like to mention. I could do a bit of WordPress work if you like. And importantly for today, I have made some small contributions to open source. Small contributions, but to big, important projects. Zen Framework 2, I've got one pull request in there. Doctrine 2 ODM, the MongoDB one, I've got 2 or 3. And most importantly, PHP conference website, where I corrected my job before it went live. It was my fault, it was wrong. I'm also in GitHub, if you're interested. And today's demos are on there if you want to run through them yourselves. It's just a script to run through. And let's get on. So, firstly, what do I mean by modern? What's the modern part of the power of modern version control? So if you go back 10, 15 years ago, something like that, you were limited to centralized version control systems, which had one main thing in common, that they had one repository. And because of that, everyone who needed to talk to the repository had to do so over network connection. That made things, well, it put a limit on the speed of operations like branching and merging. And examples include CVS. Put your hands up if you've used, you don't have to use it right now, if you've used CVS in production. Excellent. That is awesome. Subversion. That's all right? Great. As I say, in the past, it's fine. That means you guys are the hardcore, the old school are in, and you'll know what this means. So, back in the day, things were waterfall. We had massive merges to do. So when you did a feature, you had to merge it in, and conflicts were almost inevitable, and this was quite rare. So, these days, you might use what's called a distributed or decentralized version control system. And the main difference, as in the name, is that these have multiple repositories. Every developer who's working on the code and has checked it out in their working copy will have their own repository. They might have one publicly available to other people, and then there might be one that's used as a backup, et cetera, et cetera. And because of that, there's a lot of great benefit that comes from it. It meant that a network connection is only required when your repositories are talking to each other. So syncing in terms of Git, you'll do a clone maybe, or a push, or a pull, or a fetch. But the normal day-to-day tasks, like create a branch, doing a merge, rebase, we're going to talk about a bit today, commits, that's about it, don't require a network connection, which means that they can be much faster, which is great. And even more importantly for today, distributed version control systems allow for a more complex collaboration model. So a more disparate team can work together, and this makes that possible without the team having all to be able to contact the same repository. Okay? Examples include Arch, which is really old. Has anyone used Arch? No, didn't think so. Monotone? Didn't think so. Mercurial? A bit more popular. Good. And Git? There we go. Excellent. Right. So, let's talk about modern version control, which today means Git. we'll talk a little bit about Git. There we go. A brief history. So give me a shout out if you know who this is. Linus Torvalds, absolutely right. Thank you very much. So Linus is famous for, firstly, creating the Linux kernel, and possibly secondary so for creating Git. And the two stories are intertwined. The story of Git goes that the Linux kernel development team, which is just an immense team of developers who contribute to the Linux kernel. Statistics, so there was, the Linux Foundation put out some stats a little while ago. For Linux kernel version 3.2, there were 1,300 contributors. So that team was using, as its version control system, a system called BitKeeper, which was distributed version control system, and it was brilliant, really fast, it was excellent, Linus was very pleased. But it wasn't free unless you were working on the Linux kernel. They had a deal where they could use it for free. Great. And everyone was happy for a long, long time, until, sadly, it all fell apart one day. BitKeeper somehow accused one of the developers of reverse engineering BitKeeper's algorithms or its code. So the relationship broke down, and they lost the ability to use BitKeeper for free. So an alternative had to be found. So Linus and the team are looking for alternatives, yet none are up to scratch. Nothing's up to scratch of the time. Mostly because of performance. And as I say, in the same stats that the Linux Foundation put out, the Linux kernel itself, if you were to clone the repository, it's 1.5 gigabytes, and we're looking at 15 million lines of code. So when patches are applied, it needs to be really fast. Linus did some benchmarks with various different version control systems, and sometimes applying a single patch would take 30 seconds. And in one merge, you might be applying hundreds of patches. So that was untenable. So what to do? You've got a whole team of C developers, and you're a great C developer yourself. Obviously, what he decided to do was create his own. He's going to beat everyone and make his own version control system, and that is how Git was created. And incidentally, both systems, Linux is named after Linus, and so is Git. So, during the development of Git, 4 main design criteria were adopted by Linus himself. The first and most amusing one is that he wanted to ignore legacy. More specifically, he said, when we don't know what we're going to do, we're going to take what was done before, and we're going to do the exact opposite. Thus, a lot of previous legacy was destroyed, okay? And for good results. Obviously, a distributed workflow is required, strong integrity, we can't be losing code, and high performance, very important because of the size of the Linux kernel, the complexity, all those branches, and all the patches, okay? Right, foundations. A few things I just want to touch on before we get onto the really complex stuff. What's important here? So, on this first part, branches, the things that you need to know are, this diagram represents a very, very small tree of repository in Git. C0, C1, C2, C3, and C4 are commits, but what they really are snapshots of your code. So Git stores its data, or your code, as a snapshot of the code in its entirety with various optimizations so that it's not too big. But that's important. Secondly, the snapshot contains a reference to its parent so that you can form a tree. And thirdly, the branches. The branches you can see experiment, hopefully you can see, excuse me, the top one is experiment and the bottom one is master. Now, the important thing to know about branches in Git is that they are simply a pointer to a snapshot, which makes them very light, and it makes branch operations very, very fast, very fast. Okay, the second part is remotes, which isn't cut off too much. Good. So really the only thing you need to know here is at the top, we've got what would be a remote. So it's hosted on ourcompany.com. It's just a repository that we use. It's publicly available, or perhaps on the intranet, available to other people. And then we've got my computer down here, which is my working copy. And it's a repository in itself. But importantly, you can see I've got, as branches, the top one I've got is called origin master, and the bottom one is just master. So I've got a local master branch. And there's a remote. I know about the remote's master branch, and that allows me to do syncing and comparisons between the two repositories, okay? Merge versus rebase. So every so often, you've done some brilliant work in a branch, and you need to get it back into the main threads, into the main branches, and you've got two options. The first option is to merge. Ooh, that's fine. The first option is to merge. And that's what you would have always had, I guess, no matter what you were using. So the important thing to note here is we've got C3 and C4. This is from the previous slide, but we're fine. We've got changes in C3 that aren't in C4, and we've got changes in C4 potentially that aren't in C3. And we need to get them all in one place. And with a merge, what happens is the differences are calculated, and everything ends up in a single new commit, C5, and then the current branch, which is master in this case, just gets fast-forwarded, and we're done, which is great. So the important things to note are it creates a single new snapshot, and that once you're done, your history is parallel. You can still see that you had an experiment branch that you took your changes to get C5. Now, your alternative in Git, and quite possibly other version control systems, is to rebase. We'll talk about why, potentially, in a minute. But the difference in operation, you should be able to see from the diagram. Again, we had the same situation. C3 and C4 have diverged. They're different. And we want to get everything into, this time, into the experiment branch, it seems. And this time, we're going to do a rebase. So what happens is, Git will rewind your working copy back to the nearest common ancestor of the commits that you're merging, or rebasing. So in this case, C3 and C4 have a common ancestor of C2, the nearest common ancestor that is. And then what happens is we rewind the experiment branch, rather the master branch, back to C2, and then we go forward, applying each commit that was in the branch one by one. Okay, so if there were more commits in experiment, we'd still have only C5 here, just the one, but we would have more commits in the rebase, because each commit is done one by one. A very important thing to note here is that C3 dash, the dash is there for a reason. That new C3, which had been applied to the current branch, has a different ID. Okay, it's actually a new commit, and the old C3 is, well, it's floating. It's not been destroyed, but it is floating around and difficult to access, okay? Another thing that's very important is now your history is linear. It looks like you've done everything in just do some work, commit, do some work, commit, do some one, commit, which is, some would argue, cleaner, okay? So when to rebase? You've got a choice. Who knows which one, okay? So if you're going to rebase, probably the main reason is for cleaner history. Other people might ask you to rebase when you're collaborating with them because it's easier for them to see what you've done. And another use case is if you're collaborating, let's say you are contributing to Zen Framework 2 and you're doing some brilliant work and you've gone on holiday, taken a couple of weeks out, you come back, the repository that you're contributing to probably has changed. And you're going to need to make sure that you've got those changes so that you're still working on the current version of the repository, okay? And in order to do that, you'll need to do a fetch rebase from origin master, or not necessarily master, but the idea is that you bring down the changes from the remote, but first you rewind yours, you play all of theirs on top, and then you replay yours on top of theirs. So you've now picked your changes up and put them on the latest version rather than risking a dodgy merge. Next, to perform advanced functions. It's a good reason to rebase, and we'll have a look at them later. Okay, so now a couple of pitfalls. First, Right. Be careful attempting to rebase commits from previous merges. What does that mean? What that means is, so from previous merges, let's say you've done some work, you've merged it you've done a merge, and there was conflicts, okay, which can happen. You then carry on working, and then you decide that you're not happy, and you go back and you rebase from before that point. Those conflicts that happened before will happen again, because you're doing exactly the same thing again. So be careful of that. The next thing to be careful for, oh, I've gone too far. Back one, please. Thank you. Do not rebase commits that you have pushed to a public repository. That's from gitsem.com, which you may or may not have heard of, but that is the home of Git's documentation. So what that means is, so let's say, again, you're collaborating, you've done some work, it's brilliant, you push it up in order to get it a pull request, and it gets, well, let's say you've just pushed it up to a repository that's available to others. Others are then using your commits quite happily, and you then decide, oh, I'm not happy. You go back, you rebase some of those commits, and then you need to push again. Okay? Now, from your point of view, nothing's gone wrong, but anyone else who's got those commits that you've now changed, the IDs will have changed, and when they do a fetch or a pull, they're going to get merged. The same changes that they've already got, because they're new commits, are going to get merged into their code, and it's going to create a new revision, and then they're going to have to push that back up. And then you're going to fetch that, and then you're in an infinite loop. So watch out. Any commits that you have pushed to be public, you should probably consider to be immutable. Okay? Workflows. So depending on the technologies that you've got at your disposal, and the size of your team, and the distribution of your team, your workflow will be different. This is a very, very simple workflow that my team currently uses, because it's simple, and we're all in the same room, and we use Subversion. So again, if it's a centralized version control system, you're pretty much stuck with this. You've got a shared repository. All the developers check out and commit and communicate with it, obviously over a network, and it's all good, it's all easy. There's a couple of pitfalls. It does mean that all the developers have to have right access to the repository, which means if they really don't know what they're doing, or you've given them too much access, they can make mistakes. But this is great for small teams, because there's not a lot of management going on. Bless you. Back one. Thank you. So this one is a bit more complicated, and it's necessary, potentially, if you've got a distributed team or multiple teams collaborating on the same project, which is why it's pretty much what is used for the Linux kernel, I think so, but it's a good analogy anyway. So the differences are the blessed repository you can see, which is blue, is effectively what's live, and only a subset of people that are contributing can actually change it. That's the people in red, the integration managers, okay? Anyone else who wants to contribute can access the public repository, no problem, they can check it out. But in order to make their changes go into it, they have to make a public clone of their repository and apply patches to that, and then they have to somehow communicate with the integration manager. On Linux kernel, it's done by a mailing list. Everything's email. Plain text emails with headers, and you say, this is my public repository, and this is the patch I want you to pull. And then please look at it. That's what they do. So you'd email the integration manager and say, please pull my patch and apply it to the blessed repository. And then the great thing about that is the integration manager can say, OK, let's have a look. It's rubbish. Get lost. Or it's brilliant. Thank you very much. OK? So this makes the blessed repository very secure, very safe, and also allows people to be in charge of it. Okay? But anyone can potentially contribute. This is how open source works. Okay? Let's just make sure I've got everything. It's great for large distributed teams. Yeah, that's fine. Okay. This is going to get interesting. Clever stuff with Git. So, first of all, there are a couple of slides. Changing history. So, as we've said, you can go back and change things, okay? But be careful. With great power comes great responsibility. Various people in history have said that, including, I believe, right, so I did actually look this up. The first attributed, speaking of this quote, was a French author called Voltaire, I believe. But also it's attributed to Winston Churchill, Roosevelt, Spider-Man's Uncle Ben. Anyone seen that film? He says that. And Stanley it's attributed to because of that. But it doesn't matter. The point is, just because you can do a thing does not mean you should do that thing, necessarily, okay? So, correcting, back one please. Correcting the last commit, okay? This is very, very easy. There's the command, just git commit -- amend, okay? And all that will do is bring up whatever commit window you use, or maybe it's just a text editor, and what will be in there is the last commit that you committed. And you can change it, and then you can resubmit it. And no one will ever know, unless that commit was public, in which case it will have a new ID, and you're in an infinite loop, so be careful, okay? The things that you can change for doing this are the message, the files, so well, they're called objects in Git, and the code in those files, okay? So basically anything that you can do in a commit. So more complicated is changing many commits. So there are reasons to do this, but I'm not here to judge, it's up to you. You might get told to do it, in which case I'm sure there's a good reason. It's a bit more complicated, and it involves an interactive rebase. So we talked about rebase. In this case, what you'll do is you'll rebase a load of commits, and you'll tell Git, I want to change these ones, not all of them necessarily, but just these ones, and it will do the rebase, and when it gets to one of those, it will say, oh, what do you want to do? And you do it, and then what do you want to do? So that's what's going to happen, and you can amend lots of things, same as you can do in a commit amend, but also, be careful, you can remove commits doing this. So let's say you've committed a debug, and you haven't done anything else, you potentially could remove that commit. You can reorder them within reason. It's got to still make sense. You can squash, so that means combining commits and their messages together. And you can split, opposite of squash. So this is where we get brave. Can we switch, please? To this.
You need to wake up your computer.
Oh, it's gone to sleep. Is it back? Wonderful. Here we go. Wish me luck. So, where am I? Oh, it's because I'm doing the other one. There we go. So, this might cut a little bit. So, we're going to do a rebase, an interactive rebase, and all I'm going to do is change some commit messages to a repository that I made especially for this that you can see on GitHub. So, that says git k, which shows me the history. You can't quite see it, but the important thing to note is, if you see the top, that's the commit messages, and the important thing to note is that I've screwed some of them up on purpose. You can see there's missing bits there. They're not great, okay? So what I want to do is I want to interactively rebase them to, ooh, that's not good. I need to see that. I need to interactively rebase them in order to change the commit messages, okay? So the command, oh, for some reason I'm testing it. It works, brilliant. So in order to rebase them, I tell Git, that says git rebase interactive head ~6. What head ~6 means, the head is the most recent commit in your current branch, it's actually where the branch pointer is. And ~6 means -6. So come 6 commits back from the head and rebase all of those. Okay? So let's wish me luck. Oh, this is going to be fun because I can't see it. So there's my thing. Right, so you can now see these are the 6 latest commits in, well, not in reverse order because you see them in reverse order on the history, but these are in chronological order. And what I'm going to do is change the commit message for that one and change the commit message for that one. And here, it shows me what my options are. So pick means continue to use it. Reword, which is what I'm going to do. Edit, squash, fix up, exec. Play with those if you like, but not on a repository that you're not afraid to destroy. So in order to actually do things, those all currently say pick, and I'm going to go 1, 2, 3, 4. I put an R there. That's an R for reword. Then I'm going to have to find my pointer again. And then I'm going to go 1, 2, 3, 4, R. And then save, saving, exit. Brilliant. So it's done some rebasing, and now it's got to a commit that I've said I want to change. And it's giving me the commit window, and it's saying, what would you like to do? Please enter the commit message. Brilliant. So if I'm completely honest, I can't see it. So what I'm going to do is... That's a good plan. Let's try it. Oh, you geniuses. I'm under pressure. Well done. Right, so that should be added, and I'm going to guess it's based on memory, L, okay? So it used to just be AD. Save it. Brilliant. Come out, a bit more rebasing, and then we're back to another one. This one, oh, it's probably O, who knows? There we go. Bit of that. Right, now it's carried on rebasing, and it's told me it's finished. Fantastic. So what I need to do now is look at the history again and tell you what I should do, as you say. Oh, no, so you can still see. So you can see pretty much. Maybe I should just do that. There we go. Now my commit messages make sense, whereas previously they did not. And my version control administrator pats me on the back and then slaps me because they were public. No, not really. OK. That is how you do an interactive rebase. And let me just do a little bit of cleanup. What's a bit of a preview? CD, not slash. Come on. Preview. There we go. Right, back to the slides, if you please. Thank you so much. Oh, debugging. That was meant to be a surprise, but I ruined it. So, Git can help you to debug in a way. So let's say you're in a situation where you've got a horrible, horrible bug, and the only thing you know about this bug is that A, it's there, and B, how to replicate it. So you hit your web page or you run your script, and there's some horrible error, and you know this is that bug. Okay? Git will help you find the commit where that bug was introduced by doing a binary search. And bisect is a word for binary search, okay? And the idea is that it tests the minimum number of commits. So it's almost the quickest way to get there without a very lucky guess, okay? And next, there is a demo. So if we can switch back again, if you please. Promise it's the last time. Okay, so the debugging demo goes thusly. Debugging. I don't have to do any typing, so don't worry too much. It's a very similar repository. Almost the same. The only thing you really need to know about it is that I've broken it somehow. I've broken hello world. And 2, can you see in yellow version 1.0, that is a tag. Okay, and what that represents is a stable version of my code. So that's the last release, and I know it works. And somewhere between there and the head, I have broken it. Okay? Ooh. There it is. Incidentally, I don't actually have F buttons on my keyboard, so I can't F4. Right. So in this case, testing it was a good idea. You can see it doesn't work. I've managed to break hello world. Pat on the back. So in order to find where I broke it, I need to tell Git that I want to bisect, and I'm going to start. So git bisect start. The next thing I need to tell Git is that the revision that where we are currently, where our working copy is currently, is broken. So we tell Git bisect bad. Where we are now is bad. We then need to tell Git where, hopefully, the most recent good commit is. Okay? You can either do that with a tag or, to be honest, anything that describes a commit. So one of those big, long hashes, you only need to use a little bit of it. Or a tag is good. So I've used a tag. So once I've told Git this, it tells me I'm bisecting 6 revisions, and we only need really 3 steps in order to find your problem. So now it's moved the repository way back to a commit where the message was added W, and what I need to do now is test. Still broken. So my response is to tell Git that that is broken, where we are now is broken. Git bisect bad. And it moves me now. So that was bad. I know where somewhere's good. What it's done is it's gone halfway. That was bad. So now it goes halfway back towards the good. Yeah, that's how binary search works. So at this point, I test again. Huzzah. Not complete, but working. So I now tell Git, good. Okay? And I carry on. Carry on. Okay, it's moved me again. I test again. That's bad. You can see that one's broken. This one is good. That's good. And eventually, not that eventually, with a longer string commit path, it would be longer. But I'm very lucky in that I made a very small repository. So now it's telling me we found it. We know that commit 0A02, I'm not even going to do that, is the one where the issue was introduced. And it gives me the commit message, which isn't really very useful. So really the next thing to do, the next thing to do is to reset the bisect. So at the moment, our working copy has been moved in order to find this commit. We're at that commit there. So I need to reset the bisect to put us back on the head, which is done. Switch back to head. And the next thing I need to do is find out what the hell I did. So git show will show you the changes in a commit. And I'm using the hash. Well, you don't need to use all of it. So I've used just the first 6, which should be enough. And there it is. So what have I done? In red, you can see echo hello. It's all nicely encapsulated. But in green, I've added a space, like I said I did. But I've also removed the end quote. And that's how I broke it. And now I can fix it. And Git helped me. Thanks. Brilliant. OK, back to the slides, please. Right. That's how you debug. So enough about Git. Let's talk about GitHub, which is also brilliant and allows you to do mass collaboration. Another brief history, even briefer. So GitHub was founded by 3 people. Tom Preston Werner, Chris Randstrath, and PJ Hyatt. Mostly attributed to the first 2, probably specifically Tom Preston Werner. He's not there anymore, but still, he was one of the founders. And the reason is because he made it's a Ruby library that uses Erlang called Grit. And what that is a Ruby wrapper for, well, Git operations. So Grit can operate directly on Git repositories. So you don't need to go to the command line. And so Tom Preston Werner came up with the idea that it would be great, as we're early adopters of Git, that anyone can host their Git repository online, but what if we could share them with people and perform operations, and we could help each other and collaborate? Brilliant, fantastic, hold on. Everyone should be doing this. So that's how GitHub was born. It was launched in 2008 and has grown immensely. The number of repositories has just skyrocketed. God knows how many they've got now. Next one. So, back one. There we go. So GitHub, as we hopefully all know, provides a web interface into Git for easy collaboration. And that is provided by, well, HTTP, but Grit is what is the crux, i.e. you can actually do diffs directly and merges and etc. It's very clever. It also has integrated issue management and a wiki for documentation. Okay. Public repositories are free. This is good. This encourages open source. Private repositories are not free. That's how they make money and how they keep the servers running. Incidentally, if you are stuck with SVN, that's fair enough. And you can use SVN against GitHub, but the repository that you'll be talking to will still be a Git repository. So you can still talk to it like it's SVN. OK, what's next? The workflow. So GitHub is about mass collaboration, so it's bound to have something similar to the integration manager workflow, of course. But you're not stuck with it. GitHub allows you to control the permissions of your repositories. So you're perfectly allowed to make a public repository that's completely open and let everyone commit to it, if you want. Not sure why, but you can. You're not forced into an integration manager workflow. And, oh, it's gone off the bottom a little bit. That's not a problem. So, but because of Grit, GitHub's integration manager workflow is slightly different. Hopefully you can see the blue lines. They go from the developer public GitHub repositories straight into the blessed repository, which is also on GitHub. So the idea here is that the developers, in order to get their pull requests in, so they're called pull requests in GitHub as well, but they don't have to email the integration manager anymore. They just use GitHub, they make a pull request on there, and the integration manager comes along and looks at their pull requests that are waiting and deals with them, which is brilliant. It cuts out the email and to be honest, the effort, because if it wasn't this easy, would I have done it? Probably not. Okay, so the general procedure, which we're going to go through in more detail, so it's not an issue that it's cut off, is that you fork, you find the repository you want to contribute to, you fork it. That creates, well, we're going to go too deep. We'll go through it in a minute. So fork, clone, branch, code, commit, test, push, pull request, it says at the bottom. So let's go through that in a little bit more detail in a minute. First, you need to know this. If you want to make a contribution to a big open source project that a lot of people are using, it's very, very likely that they've got guidelines, they've got coding standards. There's requirements for contribution, and you need to know them because your pull request will not get accepted if you're failing in Travis or you haven't got your unit tests, etc. Okay, and if you want to contribute to Zen Framework 2, read that one. If you want to contribute to Symfony 2, that's just an index to the various requirements files. There's a lot of them. It's not that bad, but you do need to jump through a few hoops, quite rightly, in order to contribute to these. Okay, so now I'm just going to go through the workflow and try and point out any pitfalls. It's not that complicated, the workflow itself, but the pitfalls are there, and I'm going to try and clear them up now. So the first stage is fork. That's my GitHub account. So what you need to do is go to the repository that you want to fork, not yours. Go to it and press fork, and it will create a clone of it that you have full access to, and you can do whatever you like with, okay, and is also public. Next is clone. So you've now got your fork, which is on GitHub. The next thing you need to do is change some code, and GitHub's clever, but it doesn't let you do that. You need to clone your public repository down to into a working copy on a machine where you can change the code. The clever thing about this is certainly if you're using the Windows, GitHub have written a Windows client, which is actually really, really good. But I believe if you use that particular command, it will automatically create the origin remote so that you don't have to set it up yourself, which is quite nice because it's not terribly complicated, but it's just a nice step for them to have done for you. So the next stage is branch. So if you were to read Symfony's and Zen Framework 2's and probably many others' requirements for contribution, you will see that they say, please, please work in a topic branch for your own sake. A topic branch, for those who aren't aware, is essentially you've got your own master and you're going to do some work. You branch, do that work. That's your topic branch. You merge it back in when you're happy. In this case, the main reason you're using a topic branch is for good practice, but also when you submit your pull request eventually, if you were to submit it against your master and you've done loads of stuff, all the changes in your master will become part of the pull request, and you cannot select them. As in, you won't be able to say, I only want that one and that one and that one. It will be all of the changes. It's just a diff. Okay, so topic branch, and then submit your topic branch for the pull request. That's how you ring fence just the changes you want to send. Importantly, again, if you read the docs, you'll probably see in Zen Framework 2 particularly, there's more than one branch that they might want you to contribute to. Zen has it's got a master branch, which is it's like the current branch where fixes will go. It's also got a branch called develop, which is further in the future, but it's a longer looking branch. So the new features are going in there so that they can be more unstable. And that's if you're writing a new feature, you probably want to target develop. But if you're fixing something existing or just adding something small, perhaps master, okay? That's how you check out with a particular branch if you need to know. Next. Thank you. And code. So once you've got your topic branch, change the code, fix things, brilliant. So as you're coding, take note of the things that are in the documentation, like your coding standards. Perhaps take note of the unit test. If you do something that means that they need a new unit test, or you do something that breaks the unit tests, obviously you're responsible for making sure that the unit tests are enhanced or fixed. Also, documentation. If you do something that changes the documentation or adds to the documentation, they might not ask you to sort it out, but you should really. You should really. If Gary GH were here, he'd probably tell you that you must. Okay? That's it. So next, probably commit. That's not true. Commit should really be part of code. As a good practice, you should be committing often. And that's a whole other talk that we've had. Lots of speakers have said the same thing, and it's because it's true. But for this, what I mean is, make sure that your commits are clean. Specifically because if your pull request is accepted, yes, anything that you've said in your messages is public. So be careful. And don't forget to put them in as well. That's it for that one. And the next thing is to test. So once you're finished coding and committing, which is one and the same, you need to make sure that everything works, obviously. You need to run the unit tests, because Zen Framework 2 makes it very easy for you to just check them out, run them. But what's important here is that you test what is going to be pulled. So let's say you were, as we said earlier, you were on holiday, you did some changes, and you went on holiday for a couple of weeks. You then come back, and you think, oh yeah, I finished. I'm going to make my pull request. Before you do that, you must do a, have I put it up there? No, git fetch, --, rebase, origin, master, probably. Just to rebase all the changes that have happened on your target branch to your working copy, and then run the test there, so that you're testing the current code. Yeah? You also might want to make sure that no one's fixed the problem that you were fixing for you in the meantime, okay? And again, check the coding standards. So you might want to run your code through lint or code sniffer, because, so Travis, is it Travis? Yes, Travis runs on GitHub, and if it fails you for code sniffer or something, your pull request is just going to get left alone until it's green, okay? And just for a small thing like that, you don't really want to maintain it to have to prompt you. Just check the status yourself and make sure it's green. And check the documentation. So after you've tested, you can push. So obviously the process of push is you push to your fork, which is available to you. Oh, that is what it is. That's all it is. So push to your local changes to your remote repo on GitHub. And that's all it is. And then the next stage is hopefully the final stage. Woo! You might be asked to write a unit test. That's fine. So make sure, again, that you're submitting your pull request against the correct branch. So when you're ready, you go to the repository that you're contributing to. No, you don't. It's yours. That's my fork. So that's my fork of Zen Framework 2, and I'm going to make a pull request. So what I did do is press the green button to generate a diff. Okay? The next screen will be choose a branch on the target repository and choose a branch on your repository, and we will compare them. And once they've been compared, it will say, would you like to make this into a pull request? And you have to type, say, well, you have to press yes, but you need a title, you'll want a description. You need to be descriptive. What are you trying to achieve? Why have you tried to fit? Well, if it's broken, it's quite easy. But if you're trying to change something, you will have to justify yourself. And then you can submit your pull request. But same things again. Check that CI passes. Because if it doesn't, your pull request will sit there forever, probably with no one making any comments except what you're doing. Discuss with moderators once it's green, and they'll maybe say what you're trying to do. And maybe you can do it a bit better. Maybe we could do this, or maybe we should move it into this module instead. And you might be asked to squash. So this is one of the reasons why interactive rebase is useful. I think it's Symfony. In their docs, if you read them, it says, when you do your pull request, we're probably going to ask you to squash. So do it before you make your pull request and save yourself some time. So what squash means is all the changes, maybe you've been working well, you've been doing a good commit strategy, so you've got your topic branch, 10, 20 commits. What they want is 1. And and all your commit messages being the same. I don't know why, but that's what they want, and it's their repository, so no reason not to squash. And you might be asked to write a new unit test by this guy. I had to do that, or at least make sure that the test coverage doesn't reduce, which is possible. Okay? So, what are we going to talk about next? We're hopefully going to talk about the power. The power. So, we've talked about Git, and we've talked about GitHub. And why? Why? Because they give us power. And before we talk about that, there's a quote. Given enough eyeballs, all bugs are shallow. Said by Eric Raymond, but it's actually called Linus's Law. I think Eric Raymond called it that in tribute to Linus Torvalds. Okay? Now, it kind of makes sense, but what it means is you've got some code that you're using, not necessarily code that you own, not necessarily code that you maintain, but any code that you're using. The more people that are maintaining that code, the more people that are using that code, the more mature as in stable, it will get quicker. Because anyone who finds a little problem, hopefully will just fix it. And then everyone's got the fix. That's the beauty of open source. Yes, thank you. So, back. That's it. Brilliant. So the power. These days, this isn't like something that's happened last week. This has been around for years. But given that we now have distributed version control systems like Git and Mercurial, which are both very, very good, and modular frameworks, modular systems, really, anything where you can just say, I've got a new dependency, and I just want to use someone else's, and it's brilliant, and it works. So I don't have to write one of my own. Symfony 2, Zen Framework 2, Laravel, I believe, and Bootstrap, which is it's a less framework for the front end. That is a brilliant, brilliant reusable piece of code. And for the most part, you might need a dependency manager like Composer. Who's using Composer? Well done. Lots of people. Bower. Anyone using Bower? That's Composer for the front end. Brilliant. Lots. You'll also need, for these dependency managers, somewhere for them to get the dependencies. That's dependency repositories. So GitHub is a viable one, but Packagist is the default for Composer, at least. Okay, so we've got all these tools. And what we can do now is actually easily reuse rather than reinvent. So let's say 10, 15 years ago when we only had C VCS and we didn't have the easy ways to just install someone else's code and also an easy way to fix it and send it back, we probably would have just written our own, probably. Or even just get someone else's and then patch it locally and then maybe have some weird version of the library. So again, because of the more people that are using, the reuse code will be more mature. Because more people are using it, more people are maintaining it. So, yeah. All I'm saying is, I'm sure we all do it already. If you've got a problem you need to solve, first, look to see if it's already been solved. And if it has, fantastic. If it hasn't, maybe it's almost been solved. Maybe you've got a problem with assets, and ascetic is brilliant. But it doesn't quite do what you want. You can add your use case to it, submit it back, and everyone wins. It's brilliant. But if it hasn't been solved at all, maybe you could solve it, but put your code out on open source, and all of a sudden you've got everyone who's committing to open source who cares about your module helping you to maintain it. That is the power of modern version control. Okay? So, if you want to read anything, back a bit. That one, thank you. If you want to read anything more about what I've said, certainly things like commit strategy, so the internals of Git as well, I talked a little bit about that. If you want to learn about that, you should definitely read Tom Preston-Werner's blog post called The Git Parable. Brilliant. Brilliant stuff. He basically describes how Git works by telling you a story. Very clever. GitSCM.com has the main Git documentation. Git best practices has lots of links in it. Clean commits is about commit strategy. GitHub documentation, coding standards. this is a shame. This is what I want you to read. Linus Torvalds at the bottom. The Wikipedia link to Linus Torvalds. My slides are available. You can get the link from there. Learn about Linus Torvalds, because he is a man who doesn't work for a corporation. He is a man who has no sponsors. He gets his money from the Linux Foundation, and it means he can say what he likes. And he really, really, really does. So look up what he says. Oh, back one. And yeah, the last slide will go up. And there we go. Thank you very much. So go forth and collaborate, and please feedback. Not just to me, feedback to all the talks that you've seen, and the event, and the socials, because that's really useful feedback. Thank you very much. That's fine, yeah. 2 questions? Anyone? Well, you don't have to ask 2 each. If there's no questions, that's just fine. Any in there? No, it was completely covered. Oh. No, we're good? No, thank you very much. Oh, go on.
So normally, when you do the Git pull request, right?
Yeah.
And what are these kind of the managers doing? Are they kind of rebasing this change to their master, or they normally?
So the question is, what is the process of the pull request? So you make your pull request. It's essentially you're asking them to pull your changes. So it's a diff that you want them to pull. It's a patch, okay? If they accept it, it's simply that. It will just merge the changes into their repository, and then they can make them live. That's it. And they'll code review it and discuss it with you. Good? Great. Thanks. Oh, we got one more. Very quick.
One more very quickly. Thanks. There's a PHP project called Fabricator. I don't know if you're aware of that one.
I am not.
It self-hosts your Git repository.
I have actually, I was told about that not 2 days ago.
I think it's used by blender.org. So that's a useful one to have a look at.
So yeah, so what he said is that as an alternative to GitHub Private, there's a PHP project called Fabricator where you can basically host your own GitHub. Is that correct? Yeah, you can basically host your own GitHub internally, and it means your teams can collaborate over that, which is a great idea. Thank you very much. Okay, thanks.